You can't see it.
You can't touch it.
But right now, it's flowing through the wires, maybe right under your feet, powering the very screen you're looking at and running pretty much every single tool of modern life.
So, let's talk about it. This is the story of electricity, that invisible force that powers everything. And you can make a pretty strong case that it's the most important force we humans have ever learned to control. Okay, so to really get just how huge its impact is, we gotta go back in time. Back to a world that was, well, a whole lot darker and a lot quieter.
I mean, for almost all of human history, energy was this really scarce, unreliable thing, you know? Nights were lit by fire. Work, that was all muscle power. If you were lucky, you had wind for your sails or a river to turn a mill. The whole world just moved at the speed of biology and nature, not the speed of light.
But some really brilliant minds started noticing things. Little sparks, weird crackles, these strange forces all around them. And these were the very first clues, the breadcrumbs, that led to the birth of electrical science. Take Benjamin Franklin, for instance. Back in 1752, he conducted what is probably one of the most famous experiments in all of history. See, he had this idea. He wanted to prove that the little static sparks he could make in his lab were the exact same thing as the massive, terrifying power of a lightning bolt. And he actually wrote about it, in his own words, right there in the Pennsylvania Gazette. He described how this wire on his kite would draw the electric fire right out of the clouds. He collected it in a jar, and then, zap, he felt that unmistakable spark on his knuckle. And just like that, he'd proved it. Lightning was just a giant version of electricity.
Now we have to clear something up here, because this is a huge myth. If that kite had actually been struck by lightning, well, we wouldn't be talking about Benjamin Franklin, because he would have been toast, instantly. No, his experiment was way more clever than that. The wet string of the kite just acted like an antenna, conducting the ambient electrical charge from the stormy air down to that little key.
So Franklin proved the connection, which was amazing. But it was an Italian scientist, Alessandro Volta, who actually gave us control. His invention, the battery, it was absolutely revolutionary. For the very first time, we humans didn't have to wait for a thunderstorm. We didn't have to mess around rubbing amber on fur. We could just make a steady, continuous flow of electricity whenever we wanted, just by using chemistry. And that right there leads us to what is probably the single most important breakthrough in the entire history of electricity. This is where a man named Michael Faraday steps onto the scene. And by building on all this earlier work, he is about to completely change the world. Okay, so what did Faraday figure out? He discovered this incredibly deep connection between magnetism and electricity. He found that if you just move a magnet near a coil of wire, boom, you created an electric current. It's that simple. The principle is called electromagnetic induction. And here's the kicker. He had found a way to turn physical motion directly into electricity. For the very first time, the mechanical world could be turned into this invisible river of energy.
And I want you to just stop and think about how fundamental that is. Seriously. This isn't some obscure principle you learn about in a textbook and forget. It's basically the operating system for our entire modern world. Those huge generators and power plants? Yep. Spinning wind turbines? That's it. The motor in an electric car? You bet. Even the wireless charger for your phone. It all comes back to electromagnetic induction.
It's really that simple. Faraday figured out how to turn motion into electricity. And once we learned how to do that on a massive scale, well, electricity turned into modern life.
But, making electricity is one thing. Actually getting it to every single home and business, that's a whole different problem. And this challenge, it sparked one of the fiercest rivalries in science history, a battle that would decide the future of our power grid, the War of Currents.
So, you had two teams. On one side, you've got the famous Thomas Edison. He was all in on direct current, or DC, where electricity flows in one steady direction. But on the other side, you had the brilliant Nikola Tesla, backed by George Westinghouse. They were pushing for alternating current, or AC, where the flow reverses back and forth really fast. Now the key difference, the whole reason they were fighting, was transmission. AC could be cranked up to super high voltages, sent over long distances with almost no energy loss, and then stepped back down to be safe for your house. DC just couldn't do that. It lost way too much power over distance.
And Edison, trying to protect his patents, he fought dirty. He launched this really nasty smear campaign, trying to convince everyone that AC was way too dangerous. But in the end, the better technology won. Tesla and Westinghouse put on this incredible demonstration, lighting up the entire 1893 Chicago World's Fair with AC power. It was a huge success. The real nail in the coffin, though, was when they built the power plant at Niagara Falls, an AC plant, and started sending power all the way to Buffalo. That was it. AC had won. It became the global standard we still use today.
Okay, so we figured out how to make it, we've battled over how to deliver it, we've built a whole global system around it, but what is this stuff? Really, what is this invisible river that's flowing through the walls of our homes right now?
Well, when you get right down to it, electricity is surprisingly simple. It's just the movement of electrons. You know, those tiny negatively charged particles inside every atom? In materials like copper wire, the electrons aren't held on too tight, so they're free to move around. When we apply a voltage, which is kind of like electrical pressure, we just give them a little push, and they start to flow. That massive flow of countless tiny electrons, that's an electric current.
And over the years, boy, have we gotten good at controlling that flow. We built circuits to give the electrons a nice, neat path to follow. We use a switch to basically open or close a gate on that path. That's what turns things on and off. We use resistors to slow them down and transformers to change the voltage or the pressure of the flow. And of course, it all starts with a generator, which is just using Faraday's old trick of motion and magnetism to get those electrons moving in the first place.
So when you step back and look at the whole picture, the initial discovery, all the brilliant engineering, the deep science, you realize something pretty profound. Electricity isn't just another piece of technology. It really became humanity's most powerful ally.
I mean, just think about it for a second. Without electricity, none of this exists. There's no digital age, no computers, no internet, no information age. It's what powered the telegraph, the phone, the radio. It literally created modern communication. It's the backbone of the scientific discoveries that gave us modern medicine. It's the foundation of our entire global economy. It didn't just improve the world. It created a completely new one from scratch.
You see, we didn't invent electricity. It was always there. It's a fundamental force of the universe. All we did was learn how to speak its language. And in doing that, we lit up our world. So that leaves us with one last, really big question, doesn't it? What's the next invisible force out there just waiting for us to understand it that will, once again, completely redefine our future?